Okay, now let's look at question number 14, part A of Combined Mathematics 2024 A-level paper. Right, so this is the derivative question. So they have given a function here, and P, Q are real numbers. Graph of fx has a stationary point at 0, 1. Okay, and using that we have to show p equals -3 and q equals 2, right? So y equals fx has a stationary point at 0, 1. So what is the first thing we can use? So we know this point is on the curve y equals fx. So we can just substitute that point. So we know what? When f is f of 0, when x equals 0, f of 0 is going to be 1. So using that, we can create a equation. So 1 equals, substitute x equals 0, you get q minus 1 times -2. So first q value we can easily find using that. So q is equal to 2, right? Then what? How to find p, right? So to that we have to use what? Stationary point, right? So here stationary point is at which x value? X equals 0. So what is that condition? The derivative value at 0 is equal to what? 0. Stationary point is a point where the derivative value is going to be equal to 0. So we have to use that condition. For that condition, we first have to find what? The derivative, right? So let's first find the derivative using the quotient rule. So no need to simplify, just apply the quotient rule and see what you get. X minus 1 squared, x minus 2 squared, then keep x minus 1, x minus 2 here. Then the derivative of the numerator is just p, then minus px plus q. Then what do you get inside? Keep x minus 1, take the derivative of x minus 2, just 1. Then keep x plus 2 and take the derivative of x minus 1, that is 1. So that inside part just simplify. So we get 2x, sorry, this is not plus 2, this is minus 2. So we get what? 2x minus 3 as that derivative. So let's just write it as that. So this is just going to be 2x minus 3, right? So that is the derivative, right? So we need to find what? Right, we know this condition, derivative value at 0 is equal to 0, so we will use that. So substitute x equals 0. So what do we get? 0 is equal to minus 1 minus 2p, so 2p, and here 0 minus q minus 3, so x equals 0, so 0 minus q minus 3, 3q, 2p plus 3q. Denominator we don't even need to find because it's non-zero, but let's just write it out. That is going to be 1. This is going to be 2 squared 4, so just 4, right? So that is what we have. Now just from there we know 2p plus 3q has to be equal to 0. Then p is equal to 3 over 2q, and sorry, minus 3 over 2q, and we found q to be 2, so p is equal to minus 3, right? So that part is also done, right? Okay, so we have shown p is equal to minus 3 and q is equal to 2, right? For these values of p and q, show that f dash x, the derivative of fx is given by this, right? So just substitute P equals minus 3 and Q equals 2 here, and let's simplify. So let's write that down. F dash x derivative is what? X minus 1 squared, x minus 2 squared, x minus 1, x minus 2. P is what? Uh, P is minus 3. P is minus 3 minus, what do we have? Q is 2, P is minus 3, so that is 2 minus 3x times 2x minus 3. Right. Now expand the numerator and simplify until you get the correct expression. Right. So you get minus 3x squared minus 2x minus x. So minus 3x, that becomes plus 9x. Plus 2 minus 3 becomes minus 6. Then here you get what? Let's write the 4x. So minus 4x minus 6 plus 6 minus 6x squared plus 6x squared minus 9x. So you have that over x minus 1 squared, x minus 2 squared. Right. So then let's cancel any terms we can cancel. Minus 9x plus 9x plus 6 minus 6, and we are left with what? We are left with plus 3x squared and minus 4x over x minus 1 squared, x minus 2 squared. Or we can take x out, so 3x minus 4 over x minus 1 squared, x minus 2 squared. Right. So let's see if that is the expression we want to show. Right, correct. So we have done that. So next, what do they ask? Right. So then they ask, okay, find the intervals on which fx is decreasing and intervals on which fx is increasing. So this is the first derivative test. So first we need to mark the stationary points and the points where the derivative is not defined. So stationary points are what? When the numerator is 0. So x equals 0, and from here you get what? Let's find that. So we have stationary points. X equals 0 is 1. Other one is 3x minus 4 is equal to 0, or x equals 4 over 3. Right. So those 2 points are the stationary points. So local max means occur at these points, and then at x equals 1 and x equals 2, what? The derivative does not exist. So we will mark those 2 points also in the number line. So we have 0, 1, 4 over 3, and 2. Right. So using that, the number line is broken into 1, 2, 3, 4, 5 intervals. So in each interval, we need to figure out the derivative sign. That gives us what? That gives us the increasing, decreasing intervals. Right. So if the derivative is positive, it is increasing. If the derivative is negative, we know it is decreasing in that interval. Right. So we'll use test values. So let's do minus 10 for this interval. What do we need to do? Substitute here minus 10. Denominator is always positive, so we don't need to worry about that. This is going to be minus. This factor is also going to be minus. So what happens? You get minus times minus. We already know denominator is positive. So total is what? Total is positive. So in this interval, this is increasing. Then let's look at 0 to 1. So let's take test value to be half. Substitute half here. Positive, half here, negative. Positive times negative in the numerator. Denominator is positive. So total is negative. So in this interval, it is decreasing. Right. Then let's look at the third interval from 1 to 4 over 3. So let's take as 1.25 as our test value. Substitute 1.25 here, positive. Here, that's going to be negative. So positive times negative, positive times negative over positive. So again, negative. So this interval is also decreasing. Then 4/3 to 2. So let's take the test value to be 1.5. Again, let's substitute 1.5 here. So that is positive. Here, 4.5 minus 4, again positive. So positive times positive here. So positive times positive, positive. So the total sign is positive. The derivative sign is positive. So then this is increasing interval. Then in the last interval, we can take test value to be what? Anything greater than 2, let's take 10. So what happens? Positive times positive. So again, positive. Positive times positive over positive. So the total is positive. So this is also increasing, right? So the increasing intervals are what? Negative infinity to 0, union 4 over 3 to 2, union 2 to infinity. Decreasing intervals are 0 to 1, union 1 to 4 over 3, right? Then that part is done. Increasing, decreasing intervals we found. Now sketch the graph of y equals fx indicating asymptotes and turning points, right? Turning points also we can find using this number line. So we know turning points only occur at stationary points. So our stationary points are 0 and 4 over 3. So here increasing, decreasing. So here you have a local min turning point. And at 4/3 what happened? Decreasing, increasing. So here you have local max. Right. So local minimum at x equals 0, and local mean value is what? Let's find that. Local mean value is, we need to substitute x equals 0 here. So what is our function? Let's write down the function. Function fx is equal to px plus q. So q is 2, p is minus 3. So 2 minus 3x over x minus 1, x minus 2. So that is the function. So I need to substitute x equals 0 here. So 2, and here again 2, so 1. So local minimum value is 1. Right, that is done. Then local maximum at x equals 4 over 3, and local max value is what? We need to find that. Max value is, I need to substitute 4 over 3 here. So 2 minus 4, what do I get here? 4 over 3 minus 1 is 1/3. 4 over 3 minus 2 is minus 2/3. So minus 2 over 9. So that gives you uh, plus 9. Right. So local maximum value is 9. Right. So we have found the turning points, and then asymptotes also we need to find. Right. So asymptotes, look at the function. Asymptotes are the vertical asymptotes are the points where you can find them by looking at the factors on the denominator. So one is x equals 1 and the other one is x equals 2. So vertical asymptotes are x equals 1, x equals 2. Horizontal asymptote is what? Take the limit as x approaches infinity. So what do you get? This numerator degree is 1, denominator degree is 2. So this will turn into what? Limit will give you 0. So y equals 0 is the horizontal asymptote. So horizontal asymptote is y equals 0 over the x-axis, right? Okay. So now we have enough information to draw the graph. So let's mark the points 0, 1, 4/3 and 2 first. So we have 0, 0, 1, 4/3, then 2, right? And we need to draw a vertical asymptote through x equals 1 and from x equals 2, right? Then at 0, what do we have? 0, we have local mean value is 1. X equals 0, y equals 2, 1. So we'll mark that point. So here 1, 2, 3, 4, 5, 6, 7, 8, 9. So here you have what? Local minimum. Then let's mark the local max. Max occurs at 4 over 3 and y value is 9. So here somewhere here you have local max, right? So all the points, required points are marked. Now asymptote. So we could have, let's put the arrows, we will connect the correct arrows. So here you have vertical asymptotes. So right, which ones to connect is decided by looking at increasing, decreasing and local max min points. So first interval is from 0 to infinity to minus infinity to 0. So that is increasing. So here you have to go like this. This is increase in. So this one we can erase. Then from 0 to 1 it is decreasing. So this is 1. So 0 to 1 local mean, and then we have to decrease like this. So that is done. So we can erase this part. Sorry, not that one. We can erase this one. Then we have to look at 1 to 4 over 3 interval. 1 to 4 over 3 interval decreasing. So we have to just connect these two. Other, we can't connect these two. No, that is increasing. If we connect this one, this arrow to here, that is increasing. So we can't connect that. We want decreasing. Then 4/3 to 2, it is increasing. So again, we can't connect these two. No, that is decreasing. We want increasing. So we have to connect these two, right? So like that. Okay. Then what? That interval is done. Then we'll look at last interval, which is increasing from 2 to infinity. It is increasing. So which, if I connect these two arrows, is it correct? No, that is decreasing. No, we want increasing. So we have to connect these two arrows. So that is the correct shape. Graph is done. Right. Okay. So we'll do the last part in the next video.